So resistance, we saw that it is the hindrance of electric current. That is, we are controlling the current. Now, when you apply resistance, that means you have to apply the resistors. You need to put the resistors in your electric circuit. So now these resistors can be either put in series or they can also be put in parallel way. Let us first see when the resistance are put in series. So when two or more resistors are connected to each other in series, that is called as resistance in series. That is, they will be attached in the same line. When a number of resistors connected in series are joined at the terminal of the battery, then each resistance have different potential difference across its end. This you have to remember that for each resistance we need different potential difference, so we will have to put different amount of voltmeters there. So if you are putting, for example, two resistors, so that means to know the potential difference you will have to put 2 voltmeter there to identify, to calculate the two resistance, or you can say to calculate the two potential difference that is created in that resistance, and the total potential difference that will be equal. We will collect it for each, but the total will be equal. When a number of resistors are connected in series, then same current flow through each resistance. In each resistance, same current will be flown. Let's see what is resistance in series. So this is a series circuit. You can see a cell is attached here, positive and negative terminal. We have conducting wires here. This is the A terminal and this is the E terminal. Now here you can find that we have put here 4 resistance, for example. We have put 1, 2, 3 and 4. We will name it as R1, R2, R3 and R4. Now for all 4 resistance, you will have to apply different voltmeter. So we have put there 4 voltmeter. So we have written V1, V2 for resistance 2, V3 for resistance 3 and V4 for resistance 4. So this is a circuit of series. Now what will happen is whatever the potential difference that will be created, that will be V is equal to V1 plus V2 plus V3 plus V4. And R will be equal to what? R1 plus R2 plus R3 plus R4. That's it. That is the current which is flown. So the resistance will also be equal, that is R total resistance, and voltmeter, that is the potential difference that is created, that is also equal. Now, how did we get that R is equal to R1 plus R2 plus R3 and so on? So that is because we know the formula V is equal to IR, that is V, that is potential difference, is equal to I, that is current, into that is resistance, IR. So V1 is equal to IR R1, V2 is equal to IR2, V3 is equal to IR3 and so on. And I which is there, that is the current which is there, it is common, it gets cancelled, and then what remains is that is RS you can say, or you can say R total. So R total is nothing but R1 plus R2 plus R3 plus Rn. So that means the entire resistance together, that is Rs, if you have to calculate, if you have to know what is the resistance in this circuit, so you need to calculate all the resistance that you have applied. If you will add all the resistance, you will get your answer, the resistance in series. Resistance in parallel means there are two or more conductors which are connected between the same points. They are said to be connected in parallel. Now they are not connected in series manner. They are not connected next to each other, but they are connected one below each other. So that is why they are called to be connected in parallel. Also, you need to know that when the resistors are connected in parallel, the potential difference is same. So as in series, we saw that the potential difference was different for all the resistors, but in parallel, the potential difference rahega, that will be same. Now, different amount of current flows through each resistance, but the current flowing through each parallel resistance is taken together is equal to the current flowing in the whole circuit. Now, for example, we have 3 resistors in it. So all 3 resistors will have different amount of current which is flowing. So to calculate the different amount of current which is there, we will have to put 3 ammeters there, which will calculate the current which is flowing in them. And the total current, you can add it and you will get the total current which is flowing by adding all the 3 current which we get from all the 3 resistors. So this is that you have to remember in this, that only 1 voltmeter you will have to attach, because the entire the potential difference which is created across the circuit is same. And we will have to put, if you put 4 resistors, then you will have to put 4 ammeters to know the current. If you put 5 resistors, you will have to put 5 ammeter to know the current. But you can add all of them and you can know that all the entire current will be same. You can add the current which is flowing from all the resistance and you can calculate the current. Next is resistance in parallel. Now here, if you will see in the figure, we have 3 resistance here, that is R1, R2 and R3. So we have applied 3 resistors. Now to know the current which is flowing between these 3 resistors, you need to put 3 ammeters to calculate the current which is flowing. So we have put here I1, I2 and I3. And we have only 1 voltmeter here that we have applied to know the voltage, or you can say the potential difference. Now R1, R2, R3 are the 3 resistors. I1, I2, I3 are nothing but the 3 current which is flowing through it. So according to Ohm's law, we know that I is equal to V upon R. So here, as it is I1, so we can write I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. And when we will substitute all of this, so V upon R, that is this, that is I is equal to I1 plus I2 plus I3. So V upon R will be equal to V upon R1 plus V upon R2 plus V upon R3. V we will take as common here. So here our V and V gets cancelled. And what we get here is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is our final formula that we get for the resistance in parallel. That is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now here you can put the values. For example, resistance was 3.5. So you can put here 1 upon 3.5, 1 upon 2.5 or 1 upon whatever the value is that. So therefore, we conclude that the sum total of resistance in parallel in connection is equal to the sum of reciprocal for all the resistance. So that means here is the reciprocal, 1 upon is there. So this is the resistance in parallel. So this was about the series and parallel. Now next is the precaution that you need to take when you use any electrical appliances. Now this you are learning from very long time, that whenever you use any electrical appliances, whenever you use electric switches and sockets, you need to be very careful with it, because as our body has free amount of electrons, then the current can be flown through our body also. So first thing is that the electric switches and socket should be fitted above the reach of the children so that the children cannot interfere with them. Also, the wires which are there, they should not be open wires, they should be all closed inside, they should be packed entirely, the sockets should be properly put. Another thing is that whenever you are cleaning any electrical appliances, it is very important that you switch it off and then you clean it. Never clean any electrical appliances when it is switched on, because the current is flowing, and if you will add water, then there are chances of short circuit and other incidences also. Another thing is that whenever you are using any electrical appliances, see to it that your hands are dry. Do not touch any electrical appliances when you have your when you are wet or your hands are wet. Also, whenever if you are checking something or whenever you are using some electrical appliance and you are opening the wires and the switch is on, that time you can wear the footwears of rubber. You can also stand on wood, so that because the rubber and wood, they are all bad conductors, so the current flow can be stopped. Also, if any person gets shock, then don't directly touch that person, because that current can also be flown into your body. So first thing is that the switch should be switched off, and that also it should be switched off using any substance which is a bad conductor of electricity. And you can use a wooden pole, or you can also use a plastic thing, or you can use a rubber thing, anything. And also that if you have to use something, if you have to clean something, you should never wash any electrical appliances with water. And even if you are using water, dry it completely, then only switch it on. But especially do not use water. It is better to use a cloth and just wipe off the electrical appliances. So these are few precautions which we all know that we should take when we have to use the electric current, or when you are using electric current or using any type of appliances which have the electric current.